Hey everybody, welcome to Bill Sky the Assembly Guy. Another video on assembler language. We're going to do both ARM and x86-64. And before you ask, why am I wearing the baseball cap? Well, first of all, I love wearing baseball caps. Second of all, I'm having a bad hair day. I cleaned up and everything. It's just a bad hair day. It has nothing to do with the fact that I'm losing hair. Well, okay, maybe it does. But just deal with it. It's a nice Mickey Mouse baseball cap. We love Disney World, we love Disneyland, and just that's what I'm going to be doing today. So let's get to it. Extended addition and subtraction, doing larger math than you might have thought was possible based on the number of bits that your CPU. So what does this all mean? What does extended addition and subtraction, what does extended arithmetic mean? When you have data which won't fit into a register in the CPU, you can use extended arithmetic to make that happen. This means that you put one half of your number in one register, the other half in another register, and then using the carry flag, you can distribute the math between those two registers. So you effectively are creating one larger register. So let's see how to do this on an ARM processor. Let's take a look at an example. I think that's the best way to do it. So some numbers in science can be very large, very, very large. The number of protons in the universe, the number of subatomic particles in the human body. Just the number of atoms in the average human body is 10 to the 27th. Huge number. And then if you multiply that by 7 billion, which is the number of human beings on the planet, because you've been given the job to keep track of the number of atoms that humans are using up on the Earth, that number gets absolutely staggeringly large. And it just won't fit in 64 bits. So instead of just using x0, which is 64 bits, what we do is we combine, in this case, x1 and x0 together as 128 bits, and that's what I call extended addition and subtraction. So what is the procedure? Well, up on top we have this very, very large number. 1FF are the 8 bytes on the left. All F's are the 8 bytes on the right. And what we do is we divide that by 2, not mathematically, but we separate it by 2. We put the left 8 bytes in the x1 register. That's what I like to call the upper half, number 1 register. And then we put the lower 8 bytes in the x0 register, which I'm calling, in this case, the lower half, number 1. Now, what we're going to do is we want to add 100, all those 7 bytes of zeros and a 1. We want to add that to that large number that we just subdivided, or we just divided into x1 and x0. So what we do is we move the upper half of that to x3, which I call the upper half, number 2. We put the bottom half, the bottom 8 bytes, in x2, which I call the lower half, number 2. And now we're ready to do the addition. So now what we do is the next procedure is we add x2 and x0 together. We add the two lower halves. You always start with the lower halves first. So we add those two lower halves, and we add it into x4. Now we're using add s instead of just add, because add s actually will change the flags in ARM assembler language. If you just use add, it will create a carry, but it won't actually store it in any flag that you can query. So we have to use the add s. And you can see there, the lower half, number 1, the lower half, number 2 are added together. It's put into the lower half result of x4. It's all zeros because all f's plus 1 equals 0 with a carry flag. Now we have to grab that carry flag and put it in the upper half. So to do that, we use the add c instruction. And what we're going to do is we're going to add x3, which is the upper half, number 2. We're going to add that to x1, the upper half, number 1. And we're going to put that result into x5. And that's also automatically going to add the 1 from the carry flag. So 1FF plus 100 is 2FF. Add the 1 from the carry flag, and we get 300. And so our resultant number is x5 and x4 together make up that large 128-bit number, 300, and then 8 bytes of all zeros. So now how do we subtract? We're going to demonstrate this in a little while. So how do we subtract? So I just want to subtract the number 1 from my extended x5, x4 register. So to do that, we say subtract s, sub s, not sub, because sub s will affect the flags. Sub s, we subtract 1 from x4. You can see that literal hashtag 1. We subtract that from x4. We're going to put that into x2. That's a register we're done using. So we're going to put the result of that into x2. And again, we do this starting with the lower half of our number. So we say x4 minus x1 is equal to x2. x4 will be unchanged, but x2 will have the difference in there. And then what we do is we move 0 into x7 for our next instruction, because the next instruction you cannot use a literal or an immediate value like we did in the sub s in step number 1. So now we have to subtract that carry flag from the upper half, and we use the SBC, subtract carry. So we say subtract x7, which is 0, from x5, which has our 300 in it, hexadecimal 300, and that will be put in x1 after it also subtracts the 1 from that x5 minus x7, and that will go into x1. So 2FF is 1 subtracted from 300, and then our combined x1, x2 is our combined extended register, 128 bits, with 2FF and then all F's in it. All right, let's do a debugging demonstration for ARM 64-bit. I'm going to do this on Linux. Again, you can't do this on Windows. I don't know a way of doing it. You might be able to find some online emulator to do it, but it's just not as much fun as doing it yourself. So let's get to that demo right now. All right, we're back on Linux. Let's hit it. Let's go ahead and start up our ARM project. So I'm going to go into my home, my documents, my ASM projects, wherever you put it, that's fine. And I'm going to do a ARM 64-bit template. So I'm going to extract that. I'm going to rename it to ARM Extended Arithmetic 64-bit. All right, and let's get to it. So I'm just going to follow what I showed you guys in the presentation before we actually looked at code, and you could actually do that. You could just go ahead and go through that and try it on your own and then see my solution to see if you did everything right. So let's go ahead and let's do what I said we were going to do. We were going to, into the lower half, we're going to move into the lower half of our number, of our extended number. We're going to move all F's. 2, 3, 4, 5, 6, 7, 8. Okay? And actually what we're doing is we're putting the values into our numbers. So we're going to do our first number first. The lower half is x0. The upper half is going to be 0x 1, 2, 3, 4, 5, 6. And you don't have to put all of these zeros in front, but it kind of is nice to have them lined up. So that's our lower half number. So let's so this is our first number, lower half. This is our first number, upper half. Now putting comments in this in here like this is going to be really helpful for you, because as you're coding the additions and the subtractions, you can look up and see what registers you put things in, simply by the fact that you put in these comments. So it's really going to help out. All right, so what I'm going to do now is I'm going to move into x2, 0x 1, 2, 3, 4, 5, 6, 7, 8. So that is the upper half of our second number. Oh, that's the lower half, sorry. And then we're going to move into x3, 0x 1, 2, 3, 4, 5, 6, 0, 1, 0, 0. This is our second number, upper half. Now what you could do also here is you could put another comment, which I find very useful, the upper half and the lower half. So the upper half will be 0, 1, 2, 3, 4, 5, 6, and then all F's. So that might actually help you out a little bit to kind of figure out what it is you're actually doing here. So the lower half or the upper half will be 1, 2, 3, 4, 5, 6, 0, 1, 0, 0. And 1, 2, 3, 4, 5, 6, 7, 8. And so that is your first number. These comments really help. And I always like to line them up. Now, if you don't want to write comments, I can't help you. Your life's going to be a lot more difficult. You might be a savant. You might be able to keep all this stuff in your head. I can't. So I put a lot of, and I would say most programmers can't. So I put a lot of comments in there just for my own help myself out here. All right, so let's do the addition. So you always add the lower half first. So we're going to add our first number lower half to our second number lower half. And the way that you do that is you say add with carry. That's what that S does. It says affects the flags. I'm going to put it into X4, and I'm going to add my lower half from my first number to my lower half of my second number. And because I put comments in there, I know exactly what I'm doing. So now I've added those two numbers. It's going to add a 1 to all these F's. So it's going to set the carry flag. And whoops, sad. Yep, it could be sad if you don't do comments. Add lower half of the two numbers, setting the carry flag. Now we're going to say add with carry, and we're going to put that into X5, and we're going to do the two upper halves. So it's X1 and it's X3. So X1, X3. Now I always like to look at these and make sure I haven't used the wrong registers, but because I used these comments, I didn't use the wrong registers. And we're going to add the upper half of the two numbers as well as the carry flag. Now some programmers will say, well, you should only add them. You should only use the add C if the carry flag was actually set. I don't see a difference. I don't see a why. That's arguable. Somebody could argue with me about that. That's fine. A lot of it's style, but this is just so easy. So that does the addition, and we're going to do that in the debugging in just a moment. So let's go ahead and do the subtraction too, so we don't have to do two different debugging sessions. So I designed this in the presentation, and one of the things I said after doing the add C was to move into X7, 0. Because you can't put a literal at the end of the sub C, of the subtraction, borrow, carry. So we're going to move a 0 into X7. Then we're going to subtract with the sign. We want to actually affect the sign flags. X2, we want to put this in X2. X2 will be our destination for this. So we're going to subtract X2, X4, which is our lower half. You always do the lower half first. X4, and we're going to just say a literal 1. So we're going to subtract 1 from the lower half, X4, into X2. And that's going to set the carry flag. Then we do the subtract borrow, or subtract carry, or you subtract borrow from carry. We're going to put that in X1. We're done with X1 and X2. So I don't need that data anymore, so I'm just going to reuse those registers. I'm going to subtract borrow. We're going to put it into X1. We're going to say X5. X5 was our upper from the addition. X5 and X7. X7 is a 0. So all we want to do is we just want to subtract the carry flag. We don't want to subtract any additional number. If I wanted to subtract a 100, let's say, I could do that. And then I would be subtracting 100 along with the 1 from the carry. But in this case, we just wanted to subtract a 1. That was the idea of this example. And what this is going to do is this is going to subtract 0 from the upper half and the value in the carry. Let's save and build. Everything looks good. I really hope you guys are seeing the benefits of these comments, because I'm not looking at anything else right now. I'm looking at my comments to keep track of what it is I'm doing Thank goodness for comments. All right, let's debug this. So I'm going to open up a terminal. I'm going to say make debug 1. I'm going to say file, open tab, make debug 2. And here we go. So I'm going to put a breakpoint at 4000C4. Oh, what did I just do? I think I typed it wrong. Oh, forgot the 0x. So breakpoint 0x4000C4. And I'm going to say continue. All right, now we're going to put all f's into the lower half of our first number. There's all f's in x0. We're going to put the 1ff in the upper half of our extended number, which is x1. There's our 1ff. So our first number is x1 colon x0, 1ff, and then all f's. Now we're going to put the 1 in the upper half of our second number, which is x2. So you see x2 is a 1 there. We're going to put 100 into the lower half of our second number, which is going to be x3. So our second extended number is going to be 1, and then 1, and then 6 0 bytes, and then 1 0 0, or it will be 7 0 bytes. Okay. Now let's add the lower half, x2 and x0, put that into x4. We're going to add with carry. Now, why did that come up with 0? Why does x4 have 0? Because we added x2, which is a 1, and all f's, which is a 0, which is an x0. So 1 plus all f's is a 0, and the carry flag was turned on. So now we're going to add carry x3, which is 100, and x1, which is 1ff. That's going to give us 2ff, along with the carry, which is a 1. That's going to give us 300. And I'm going to move my mouse up here and press my scroll button. And we can see the 300 in x5. So now our number is x5 colon, I believe it was x4. So it's 300 and then 8 bytes, all with 0. So now we're going to move 0 into x7, which already has 0, but we didn't know that. So I'm going to add 7 into there. I'm now going to subtract 1 from x4, and we can see x4 right there has a 0. I'm going to subtract 1 from x4, put that into x2, and x2 now has all f's, and the carry flag has been turned on because when you subtract 1 from all zeros and you get all f's, the carry flag is turned on. So now I'm going to subtract carry from x5 and subtract x7, which is a 0, from x5. x5 right now is 300, so I'm going to subtract 1 from x5, which is going to give me 2ff. Because that 1 came from the carry, x7 has a 0 in it, so it's still 2ff. And we're going to put that in x1. So we can take a look. x1 is 2ff, x2 is all f's. So the result of 3 0 0, all zeros minus 1 is 2ff and all f's. I'm going to continue, quit my debugger, and that's the debugging demonstration for ARM 64-bit. Okay, so that was our coding demonstration. I recommend that you go through the video and you take a look at what I did, and then in your programming environment, go ahead and replicate what I did. Go ahead and do it yourself, try it out, and then look at the video solution that I've got as well as to how I did it. Get used to this, try some different numbers in there, see what they do. Practice, practice, practice. It's up to you to become an expert. I'm just trying to get you started. Hope to see you at my next video.